introduction of the course, and some initial contents of the course will also be covered. During this lecture, we have to cover first of all course outline of the course, then we have to discuss uh, text and reference books which we will be following. Then there is the assessment plan, and before we go to the microprocessor, brief history of computing, or you may say that evolution of microprocessor will be discussed. Then microprocessor based system will be discussed with the help of a block diagram. Then what is microprocessor and how it works, that will be discussed. Then the pin diagram of 8088 and 8086 microprocessors will be discussed, and after that some pin functions of 8088 8086 microprocessors are discussed in connection with demultiplexing of address bus and buffering of data bus and control signals. That is the course outline we have to cover. Today's lecture is lecture number 0, and we have to conduct total 11 lectures from 0 to 10. So in addition to the introduction of the course, we have to cover hardware specification topic for the concerned microprocessor 8088 and 8086. In lecture number 1, we have to cover the internal architecture of the microprocessor. In lecture number 2, we will be covering real and protected mode memory addressing. Then in lecture number 3, addressing modes for instructions will be covered. Then we will be discussing the instruction set for the 8088 and 8086 microprocessors. Then we will be covering assembly language programming. Then memory devices will be discussed, and how to interface microprocessor with memory, that will be discussed. After that, we will be covering IO interface topic, then how IO devices uh, may interrupt microprocessor, that will be discussed, and in the end, the last topic is direct memory access. That is the textbook written by Barry, and the name is the Intel microprocessors and name of all processors uh, till now, and the architecture, programming and interfacing. Our concern is our scope of this course is 8088 and 8086 microprocessors, and there are two reference books. Uh, First one is 8086 and 8088 microprocessors. Second one is microprocessor and interfacing. Assessment tools. During this course, two quizzes, online quizzes will be held during classes, online classes, and expected weeks are 2 and 8. For assignments, I have decided week number 6 and 9, and there will be mini project, and the submission of that project will be in week number 9. Before we start core topics of our course, we have to go through the history of computing machines invented by scientists. So first stage of invention is called mechanical age. In mechanical age, Babylonians invented abacus, a mechanical calculator for, used to perform calculations by using a string of beads. Then in 1642, Blaise Pascal designed a calculator, and that mechanical calculator used to perform calculations by using gears and wheels. And 1823 onwards, Charles Babbage designed analytical engine on paper, but at the time of implementation of that analytical engine, Charles Babbage found that 50,000 mechanical parts with precisions are required, so that analytical engine was not made physically. Then, after invention of electric motor by Michael Faraday in 1800s, electrical age starts, and many of the scientists invented their electronic calculating machines, and some of those electronic calculators were used for different purposes in World War II. The last of the electronic calculators was ENIAC, electronic numerical integrator and calculator. That calculator was having 17,000 vacuum tubes, and in that calculator there was 500 miles of wire, and weight of that calculator was over 30 tons. So that was a huge machine. The size of that machine was very big. So then after that, with the invention of transistor in 1943, microprocessor age starts. Then first IC was made in 1958 at Texas Instruments, and then the technology advances, and first microprocessor was invented in year 1971. A 4-bit microprocessor titled as 4004 was invented by Intel scientists, and in the same year 1971, Intel introduced first 8-bit microprocessor named as 8008. The advanced version, the improved version of that 8-bit processor was introduced in year 1973, and name of that microprocessor was 8080. That was also of 8-bit. The last 8-bit microprocessor was introduced in 1975, and the name of that processor was 8085. Then, with the invent of 8086 microprocessor in the year 1978, modern microprocessor age starts. 8086 was first 16-bit microprocessor, but at that time all the systems having 8-bit microprocessors, and the microprocessor communicates with external devices by using 8-bit data bus. 8086 was having 16-bit data bus, so Intel introduced a version of 8086 in 1978 79. That version was having 8-bit external communication, or you may say that the data bus of that processor was of 8-bit. So 808 was used in the existing systems for replacing the 8-bit microprocessors. Then in 1983, Intel introduced 80286, the updated version of 8086. Then in 1986, first 32-bit microprocessor was introduced, 80386. Then 486 was introduced in 1989. Pentium processor was introduced in 1993. Pentium Pro was introduced in 1995. After that, Intel introduced Pentium 2 in 1997. Pentium 3 was introduced in 1999, and last 32-bit processor Pentium 4 was introduced in 2000. 2001 onward, Intel introduced multi-core processors and 64-bit processors. As nowadays you are using Core i3, Core i5, Core i7, and you are having different generations of these processors in your laptops and desktops. So that is the brief history of evolution of microprocessor. Now we go to the so in this slide you may see a block diagram of a microprocessor based computer system. So the main unit here is microprocessor, and wherever you will be having a microprocessor in a system, you have to provide program or instructions by using some permanent storage device. So you must be having some memory system there. And as you see in your computers that you are having keyboard, you are having LCD, and you are having mouse, and you may take print out of the computer. So there must be IO systems there present in your computer. So whenever microprocessor wants to communicate with memory system, it uses its buses, and there are three types of buses. First one is address bus, second one is data bus, and third one is control bus. So microprocessor generates addresses. In response of address, memory system provide data, and that data is some kind of instruction. Microprocessor receives that instructions and decodes that instructions and identify which operation is to be performed, and then that operation is performed by microprocessor. And in the instruction side of microprocessor, there will be some instructions to access input output devices or system. So same is the case here. Microprocessor will generate an address, and that address will be of a particular input or output device. That device will communicate with microprocessors, and all the remaining input output devices will remain in idle state. So address identifies which input or output device is to be accessed, and data will travel through data bus. If microprocessor is accessing input device, data will travel towards processor, and if there is an output device, then microprocessor will output data through data bus to that output device. Here you may see that different type of memories are listed. So you may have DRAM, SRAM, cache, read-only memories, flash memories, double EPROMs, SDRAM, RAM bus, DDRM. Or you may have one of these listed microprocessors, 8086, 8088 till Core 2 processors. So our scope is to cover 8086 and 8088 during this course. So we will be focusing on these two microprocessors, 8088 and 8086. In IO systems, you may have keyboard, mouse, or printer and monitor. These are all the input output systems you may attach with microprocessor. Now we have to discuss what is a microprocessor. As the name shows, there are two parts, micro plus processor. Micro indicates its size, that the size of microprocessor is very small, and processor means it processes data. And data is of two types. Number one is decodable data, and number two non-decodable data. And detail of these types of data will be coming in the coming lectures. And microprocessor will be available in IC form, integrated circuit form, and that IC will be having number of transistors in it to generate microprocessor operation. Whenever there will be a microprocessor in a system, that will be accessing memory, system and IO devices with the help of buses, and these buses are of three types. Number one, address bus, number two, data bus, and number three, control signals or data control bus. In a computer system, microprocessor will be performing three main tasks. Number one is microprocessor will be performing data transfer operations between itself and memory device or IO devices. Number two, microprocessor will be performing some arithmetic and logic operations by using its ALU, arithmetic logic unit. And number three, microprocessor will be controlling uh, the flow of program by taking some decisions based upon some flags present in it. In this slide, uh, the chip of 8088 and 8086 microprocessors is shown. The chip is available in dual inline package. So 20 pin per side, total 40 pins are there in the chip of 8088 8086. Pin number 1 and 20 are for ground. So both of these pins will be connected with 0 volt. And there is a pin number 40 VCC. That pin will be connected with plus 5 volt. When these power signals will be applied, microprocessor chip will be in working condition. Now this 8088 8086 microprocessor perform may act in two modes of operations: minimum mode or maximum mode. You may see at pin number 33, label is min slash max bar. So if you apply plus 5 volt here, then microprocessor will be working in minimum mode, or otherwise if you apply ground here 0 volt, then microprocessor will be working in maximum mode. And the pin functions for minimum and maximum modes are different. So you may see that some of the pins are having dual functions. So these differences in minimum and maximum mode operations will be discussed later. And minimum mode 8088 and 8086 operations are also different for some of the pins. So these differences will also be covered in the coming lectures. Till now we have discussed three microprocessor pins: VCC and ground and minimum maximum. There are two ground pins, so that will be having 0 volt, single VCC pin that will be connected with plus 5 volt, and whatever operation we require, minimum mode or maximum mode, so we will be connecting minimum maximum pin according to that requirement. Now onward we have to discuss address data multiplex bus AD0 to AD7 for 8-rated microprocessor, AD0 to AD15 for 8086 microprocessor. In case of 8-rated microprocessor, dedicated address lines will be discussed, A8 to A15, and address status multiplex bus will be discussed, A16 S3 to A19 S6. ALE pin will also be discussed, address latch enable pin. Then we will be discussing DEN bar pin for data bus enabling, and data transmit slash receive pin will also be discussed, DT slash R bar. Then in the coming slides we will be having figures for demultiplexing of address from data and status, and bidirectional buffer will be used for data bus buffering, and unidirectional buffer will be used for uh, buffering dedicated address lines and control signals. In this slide we are having a figure 9-5, and you may see that the address data multiplex bus AD027 is connected with a latch 74373 IC. At the output of the latch you will be having address only A0 to A7. Output enable pin of the latch is connected to the ground, so that the output lines of latch are enabled for the for whole duration of the operation. And G pin is called latch enable pin, and that is connected with the ALE of microprocessor. Microprocessor works in such a way that whenever there is address at 18 or 27 lines, ALE will be in active state, or you may say that ALE will be at logic 1. So latch will be enabled, and whatever pattern of address is present at the input side of the latch, that will be passed to the output. In this slide, we are having a figure 9-5, and you may see that the address data multiplex bus 18 or 27 is connected with a latch 74373 IC. At the output of the latch, you will be having address only A0 to A7. Output enable pin of the latch is connected to the ground, so that the output lines of latch are enabled for the for whole duration of the operation. And G pin is called latch enable pin, and that is connected with the ALE of microprocessor. Microprocessor works in such a way that whenever there is address at 18 or 27 lines, ALE will be in active state, or you may say that ALE will be at logic 1. So latch will be enabled, and whatever pattern of address is present at the input side of the latch, that will be passed to the output lines, and you will be having A0 to A7 at the output of the latch. Next 8 address lines A8 to A15 are dedicated address lines, so there is no need of latch here, and you are having A8 to A15 without any latch. Last 4 address lines A16 to A19 are multiplexed with the status lines S3 to S6. So for demultiplexing address from status, you have used second latch 74373. In the next figure 9-7, in addition of the latches at 18 or 27 and A16 to A19, you are having bidirectional buffer 74245 IC connected with the multiplex address data lines 18 or 27. Bidirectional buffer works in such a way that uh, it can communicate from A side to B side, or it may transfer data from B side to A side depending upon the logic level of DIR pin. You may see that DIR pin is connected with DT/R bar pin of microprocessor, and there is another pin G, that is low enable pin, that is connected with the DEN bar of the microprocessor. So whenever there is data at the 18 or 27, DEN bar will be in active state or will be at logic 0, and that will enable that bidirectional buffer IC. For choosing the direction of the flow of data from A side to B side or B side to A side, DT/R bar will be having logic 1 or 0. If microprocessor has to transmit data towards memory or IO device, DT/R bar will be having logic 1. So data flow will be from A side to B side. Whenever microprocessor has to receive data from any device, dt slash r bar will be having logic 0. So data flow will be from B side to A side. So bidirectional data buffer is present for controlling the data bus. In addition of that bidirectional buffer, there is a single unidirectional buffer at dedicated address lines. So A8 to A15 address lines are buffered using unidirectional buffer, and also you may see that IO slash M bar, read bar, write bar, these three control signals are also buffered by using unidirectional buffer. So that is called fully buffered age-rated microprocessor system. In this slide, you are having a figure 9-6. In that figure, you may see that there are two latches 74373. Output enable pins of both of these latches are connected with ground, and enable pin, latch enable pin, G pin of both latches are connected with ALE pin of microprocessor. So according to the latch operation, input side of latch is connected with output pins of latch if OE pin is grounded and G pin is having logic 1. So you may see that input side of latches are connected with address data multiplex bus AD0 to AD15. 8 pins AD0 to AD7 are connected with first latch, and AD8 to AD15 are connected with the second latch. So at the output of latch, you are having address from A0 to A15. So whenever there will be address present at AD0 to AD15, AL will be in active state, or you may say that AL will be at logic 1, and address will be present at output pins of latches. So you will be having A0 to A15 address present at the output of latches. Third latch is connected with the address status multiplex bus A16 to A19. So same is the case for with the third latch. OE is grounded and G is connected with ALE pin. So whenever there will be address at these pins, latch will be enabled and output will be having address pattern A16 to A19, and BHE bar is also demultiplexed from status pin S7 by using this latch. So BHE signal will also be demultiplexed. In second figure 9-8, in addition to the latches, there are two bidirectional buffers connected with data bus, address data multiplex bus, AD0 to AD15. So first buffer is connected with AD0 to AD7 pins, and second buffer is connected with AD8 to AD15. The direction pins of both buffers are connected with DT slash R bar pin of microprocessor 806, and G pin, which is enable pin, low enable pin for buffer, bidirectional buffer, that is connected with DEN bar of microprocessor 806. So both of the buffers will be enabled when DEN is having 0, and DT slash R bar will be having 1. Then communication will be from microprocessor to the devices, IO and memory, and whenever there is a logic 0 at dt slash r bar, data will be received by microprocessor from memory or IO. Last four address lines are multiplexed with uh, status lines, and those are demultiplexed by using the third latch. And signal direction buffer is connected with m slash IO bar, read bar, and write bar. So both of all of these three control signals are buffered by using a unidirectional buffer.